Hello everybody and welcome to part 2 of the video for notes for assignment 9 in ABS. In the last video, just as a quick recap, I went over how to graph ordered pairs, what the coordinate plane was, how you find the quadrants, all that fun stuff. And in this video, I'm going to go over how we can graph lines using an XY chart. So you can see here, this is what we're doing. And way up here, I have a process for that. So let's get into it. The process would be, we need to solve for y and simplify the other side. And as we get deeper into examples, you'll see what this first step actually means. Step 2, pick x values that make sense. And for this course and for the video, I'll be choosing three points just to make sure that they all land on the same line. And x values that make sense, again, I will let you know what that means as we get into examples. The third step, find y values paired with the chosen x's. So the cool part that I mentioned, at least in the last video, is that the x values are independent. We can choose those. The y values depend on the x values we choose. That's what makes the y value dependent, or the y variable the dependent variable. So when we choose our x's, we will use the equation to figure out the y's that are paired with them. That will give us the ordered pair. The last step is to plot the ordered pairs, connect the ordered pairs, or connect the points. Extend, you'll see what I mean by that, and use arrows, and maybe, just maybe, you can be a little bit fancy about it as well. So let's go ahead and start with example 1. Example 1, you'll notice that the equal sign splits our equation into two different sides. We've got the left side and the right side. So on the left side we have y, and whenever we say solve for y, you have to isolate the y. On the right side, we have 2x plus 1. So up here, when I said you want to simplify the other side, well, y is already isolated. We need to simplify the other side if we can. And that just means performing any distributions or combining any like terms. And we don't have any of that here. We cannot combine these two terms because 2x and 1 are different, they're unlike terms. There's no distributing to happen here, so we're already simplified on the right side. So we pick x's. Now, normally you'll just pick the following x's. We want -1, 0, and 1. It's that simple. It will change slightly in a couple later examples. You'll see it when I get to it. So now, what do? Step 3. Find the y values paired with those chosen x's. So what I do is I write the equation that we were given, 2, but instead of x, I'm going to substitute in one of the values. So say -1. I'm going to start with -1. And we can simplify down the right side. So 2 times -1 is -2 plus 1, and then y would equal -1. So what this means is we knew that x equals -1 because we picked it, and when x equals -1, y equals -1. So I'm going to put this -1 in the y column next to the -1 x. And we do this with all of them, so I'm going to change the 0 here to a different color so you can see what's going on here. So I'm going to do this now, y equals 2 times 0 plus 1. So now our x is 0. Well, when you simplify all this down, y becomes 1. So when x is 0, y is 1. I'm going to pick yet another color here. Let's see. Let's make this one black. There we go. Y equals 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. So when x is 1, y is 3. So we found the y's that are paired up with the x's we chose. The last step, we want to plot these ordered pairs, so 1, 3, so you can see why knowing how to plot ordered pairs is important. There it is. 0, 1 is right there, and -1, -1 is right there. And again, the reason we choose 3 ordered pairs is to make sure that they all line up on the same line. So just judging on my ruler there, it seems as though they're all lining up pretty well on the straight line. So what you want to do then is you want to connect all of those. You want to extend past those points, and then you want to put arrows at the end. And that's it, and that's all there is to drawing a line. You can be fancy if you want to, and you can label this line right along with how the line is sloping. So I'll have y equals 2x plus 1, something like that. So now we know, without having to look way back over here, what the equation of that line is. All right, let's jump to another example. So here we have example 2, and this example is very similar to example 1, where step 1, we have to solve for y, check y is already isolated. We have to make sure that the other side of the equation is simplified, check. There's nothing to distribute, nothing to combine, so we're good to go. So let's pick some x values. So again, I'm going to say -1, 0, 1, like that. I am going to let you all see if you can figure out these x values here, or the y values here, or you can take my word for it. This would be 1. So I have these 3 y values that get paired up with the x values. See if you can figure out those y values. It's really important for you to know how to do that. I'm skipping those steps to make this video a little quicker. But here we go. We've got -1, 7. That is way up here. We've got 0, 4 right here. And I have 1, 1 right here. And again, you can use any straight edge. I have a built-in ruler here, but you can use an ID, you can use a library card if those are things that still exist in the 21st century. You can do lots of things. So let's see. It all looks like they're pretty well on the same line there. I'm gonna see if I can line this up. So you want to connect the dots. There we go. You want to extend past the dots. So we plotted, connected, extended, and then we want to just make sure we get the arrows on the end. There, there. And if you want, you can label it. This is y equals -3x plus 4. And there you have it. You've got that line. Example 3 is our first example with needing to solve for y. So in order to solve for y, you want to make sure you have all the terms with y on one side and all of the terms without a y on the other. So what I'm seeing here is, on the side with y, I've got a term with y, and I have a term without y. In order to move the term without y, aka this term right here, to the other side, I have to either add or subtract whatever's the opposite of this sign here. In this case, it'll be add. I have to add that to both sides, so it'll look something like this. So I just rewrote the equation over here so I could put the step underneath it. Again, the equal sign breaks the equation into a left side and a right side, and we are trying to get rid of this x term. The opposite of subtracting an x is adding an x. Those will reduce, but what we do to the left side of the equation, we also have to do to the right side of the equation. So yes, these do cancel, or we say reduce to 0, and we are left with y equals x minus 3. Now that was step 1, part of step 1, we had to isolate the y. The second step to part 1 is you have to ask yourself, is there anything on the other side of the equation from the y that we have to simplify? In this case, no, we're done here. So what I do then is I pick my same 3 values here. And yes, you can pick -1, 0, and 1 in most cases. So let's see what this does here. If you substitute -1 in for x here, -1 minus 3 would be a -4. 0 minus 3, if I use the 0 here in for x, would be -3. 1 minus 3 is -2. So you can plot those points, you can connect those points, you can extend the line past those points, you can put the arrows at the end of the line, and if you want to, label it. And I think I'm going to end the second part of the video here, because the next part gets into still graphing lines, but it's a little bit different from what you've seen before. So I hope this makes sense. I wish you well in learning this topic and learning more about graphing lines in the next video, which should be popping up on screen right about now. Good luck, everybody.